This is John from caveofprogramming.com. I wanted to add a video to this course just explaining a bit about C++ design considerations, in particular in the context of the program that we've developed in this course, which is this particle fire simulation type thing. So as I went along, I kind of explained how the various classes worked, but I didn't really explain why I implemented them in the way that I did, which is a bit of an omission. So I wanted to talk just a little bit about design in C++. I've never been a big fan of designing everything up front and then trying to code what you've already written, because I think even the best software developer in the world is going to discover new things and get new ideas while they're actually implementing something. And indeed, we've seen historically that if you do upfront design, where you design everything in advance and then try to implement it, we pretty much usually expect to get time overruns, schedule overruns, or budget overruns if you're having to pay for the development. So I much prefer an iterative approach where you try firstly to get some sort of very basic prototype together, or at least you try to demonstrate some of the key things that your software is going to have to do, like making a sound or creating a window and writing pixels on it. And then you kind of add bits to that software and you continuously build the software at every stage. Just build it like crazy. If you've got a huge program, that might have to be overnight, every night. But with a smaller program like this, we can afford to just add little bits of code and then immediately build it to check that the code we've added makes sense. And personally, I'm a big fan of that approach. So I won't talk about upfront design because it's not something I'm a fan of, and I'm not good at it. I'm just going to talk about the thought process I had to go through to put this program together. So as you've seen, if you watched the other videos, the first thing I did was put together an SDL demo program, and that kind of did all the basic SDL initialization code. I don't have that stuff in my head. I just looked at various bits of example code and SDL documentation and gradually put together a little demo program, because I think it's important to test anything in your program that might be contentious, that might not work on your system or whatever. And here we wanted to create a screen and write pixels to it using a library that we hadn't seen before. So it makes sense to kind of get a little demo program together, just a really small program, to test all this stuff with renderers and pixels and everything, creating windows, and check that it works and that we understand how to do it. So that was the first stage. And then the second stage is, once I got all this code, which initialized SDL, just drew some pixels and then closed down SDL, then I kind of looked at it and said, well, okay, this is a good candidate for putting in its own class, because originally we had all this kind of code, initialization and destruction, in the main program, but it's all related to one function. It's all basically aimed at drawing at the screen. So it seemed like a good idea to put that all in a separate class, get it out of the main function so it's not cluttering up our main program, encapsulate it in its own class. And for that reason, I created this screen class that does all that. Now, there was a bit of code that wasn't directly related to actually the business of drawing things on the screen, and that was this code that processed our events. So it checks what the user's pressed, if anything, and takes an appropriate response. And here that was you can see that's a very, very small amount of code. So I figured, okay, that this isn't going to expand, let's just put it in the screen class. Arguably, processing events is also related to your window. This is kind of a class that deals with window related stuff like drawing, so arguably that's not a bad place to put it. But if I'd had a lot of event processing going on and it was complex, then I might well have created a separate class called handle input or something that is just related to handling input. But in this case I put it in a screen class with the drawing code. Now, once I'd got that, it was clear that we were going to need to deal with particles. We don't want to, if we're dealing with some distinct entity like a particle that bounces around the screen, that's a kind of obvious candidate for putting in its own class. So I created a particle class, and that was pretty straightforward. We don't want to sort of have separate bits of code dealing with the same thing, the same pixel that's moving around. Okay, it's actually different pixels being illuminated, but conceptually we're thinking of this as being a particle that's moving around, so it makes sense to encapsulate that in its own class. And we don't want to kind of splatter different bits of code related to the same function throughout the software. We don't want some code in one place that kind of moves particles, and another bit of code somewhere else that changes the color or whatever. We want to encapsulate that in a class. So just kind of looking at it and thinking about it, that a particle class seemed like a good idea. If we had a game and we had, let's say, a spaceship in that game, then of course that's just conceptually, from a human point of view, that's a distinct object, and so we'd probably want to represent that by some sort of spaceship object in our class. And of course that could be part of a hierarchy of classes, where we could have a base class that draws something on the screen, and then we could add different kinds of behavior and get different subclasses to use different graphics or whatever, just as necessary. So we could create different objects in our game like that. But it's clearly a good candidate for its own class. And when I had the particle class, it was pretty clear that we were going to have to deal with big groups of particles, and we've got to put that code somewhere. We don't really want to put it in the screen class, because the thing is that the screen class is a pretty reusable class. We could take this screen class, which just deals with setting up SDL, closing it down, minimal event handling, and drawing stuff to the screen from a buffer. We could use that in any program, so it's really reusable. And if we started putting stuff specific to our program in this class, like code relating to particles, we can't reuse it anymore. It's then forever tied to dealing with particles. So once I got my screen class, I wanted to keep it separate from other classes, with the idea in mind that it's reusable. And we also don't want to tangle it up unnecessarily with other code that really has nothing to do with this basic business of creating a window and enabling drawing on that window. So I needed some class that was going to organize particles. That was clear. I didn't want to put that in my screen class. I wanted to keep that as it is, so it's nicely reusable and self-contained. And I didn't want to clutter up my main.cpp here with code that has to manage a whole swarm of particles. So for that reason, I created this class swarm. And the point of this is just to deal with a whole collection of particles altogether. So that also kind of makes sense if you just think about this program, just conceptually. Clearly we've got individual particles here, and clearly we're dealing with a swarm of them there. So just by thinking about what's in that program from a human point of view, it kind of clues us in to what classes we might consider creating. So I created this swarm class that can manage a whole bunch of particles. It doesn't do very much. It's really just creating the particles, deleting them later on, which we can handily do in the constructor and destructor here, respectively. And I've also given it an update method, because we need to update the positions of particles. And since we've put the game loop in main.cpp, we're going to have to update them in this loop. But if we've got a class that deals with a whole collection of particles, then it makes sense to get that class to do the business of visiting each particle in turn and updating its motion. So rather than, again, if the whole purpose of this class is to deal with an aggregate of particles, a whole load of particles, so we want to try not to have code anywhere else that's dealing with individual particles, otherwise that's kind of defeating the purpose of this class. So I created this update method, and then that deals with each of the particles in turn in the whole swarm. And in main.cpp, we only need to call the swarm update method to update each of the particles. Now, a key design consideration here is to keep the swarm and the screen class separate for the reasons I've mentioned. We've got a nice reusable screen class, then we've got a very specific swarm, particle swarm class that's really only for this program. We can't, well, having said that, even the swarm class potentially could be reusable. Inevitably, because we're using SDL, I've ended up splattering SDL code slightly throughout much of the program. But if we look at swarm.h here, swarm.cpp, let's see, swarm.cpp, there we go. I don't think there's actually anything SDL specific in here, which is really good, actually, which is what I wanted. Because although, yeah, inevitably the screen class is going to have to make a lot of use of SDL, by implementing the swarm class as separate from the screen class, this also means potentially that we could even use the swarm class in a different program. So we could use the screen class in other SDL programs. We could also use the swarm class in a different program that uses a different graphics library to SDL. So I'm always thinking when I create these classes, can I write them in such a way that they don't depend on other classes, or they have minimal dependence on other classes in my program, so that they could be taken into another program that works differently and reused there. Now, of course, somehow somehow we have to connect the swarm and the screen. And what I could have done here was I could have given the screen class some sort of method that accepts a reference to a swarm class, but then I'm tying it to the swarm class. Because neither of them are so easy to reuse anymore. Well, the screen class is not so easy to reuse anymore. I suppose I could still reuse the swarm class. But what I did instead was I made swarm return nothing but a pointer to a load of particles. And I thought, well, it's nice if we don't even have to have the screen class referring to particles. So I made it so the screen class just has this set pixel method, and then all we need is some code that loops through the buffer of particles and then calls screen.setPixel. So we managed to completely separate the swarm class from the screen class. There's no connection between them. They're both reusable. Swarm has to know about particles because its whole task is to manage the particles, but there's no connection between that and the screen class. There is quite a lot of code in main.cpp. If you've got a very big program, you might want to try to aim for a main.cpp that's cleaner than this. And then we could have perhaps some sort of separate class that does know about swarm and does know about screen and brings those two together somehow. That's just going to be a little class with kind of this kind of code in it. And that class clearly is not going to be very reusable, but it's just going to be a small class containing this kind of code here. So that's not so bad. We've still got swarm and screen are still very reusable classes. But because it's quite a small program, I opted just to put that in the main function. It's not too bad. You can see pretty much almost at a glance with a bit of practice what's going on here. The box blur algorithm, that was something that I kind of thought about, and in the end I decided to put it into screen. We could have had some sort of separate box blur class, or some sort of blur class that implements various blurs, and somehow we could have tried to separate that from the screen class. But I figured if I reuse the screen class, it's nice to have the option of blurring the screen anyway. I'm not sure there's a huge advantage in this case to separating out the blur from the screen, but that's also something that we could have thought of instead of implementing the blur code in the screen class. Okay, so that's basically it, and the kind of basic message is try to make your classes depend on each other as little as possible. Try to encapsulate them and try to always think, could I use this class in a different program that maybe uses different APIs, or that works very differently to the one I've got. Try to make your classes reusable and self-contained with minimal dependence on other classes. And inevitably you can't do that all the time, but we've managed to do it somewhat, at least in this program. Okay, that's it for this tutorial. I hope you enjoyed the course. Until next time. Oh, one more thing actually. Yeah, I've started work on an advanced C++ course, and if you want more information about that, do go to caveofprogramming.com. So until next time, happy coding.